Hello everyone, and welcome to today's video where we'll be talking about Jefferson's method, which will be discussed by me and my members. Now, to start off with the video, I would like to introduce or have an introduction on what Jefferson's method is all about. Now, before, a man named Thomas Jefferson proposed a different method for apportionment. By Jefferson's method, instead of the standard divisor, we use a modified divisor and recalculate the lower quotas until they add up to m. Now, as long as the surplus is positive, we try a smaller modified divisor. That is what Jefferson's method has given. Now, as long as the surplus is negative, we try a larger modified divisor. Now, and it has been said that Jefferson's method was used from 1791 until 1842, when it was replaced by Webster's method to come later. Now, in Jefferson's method, this involves repeated guesses until we find a number that works.
The D'Hondt method, sometimes referred to as Jefferson's method, is a highest average approach to allocating seats in a proportionally represented or representative body. Thomas was the one who first suggested it. Jefferson in 1792 and Victor D'Hondt on his own in 1878. The technique divides assigning seats to the parties after dividing the total votes of each party by a number of divisors, 1, 2, 3, 4, and so on, until every set has been allocated using the highest resulting quotients. This approach tends to favor larger parties as opposed to smaller ones, which distinguishes it from other apportionment techniques like Hamilton's approach. Many nations, including those in Europe, use it extensively for parliamentary seating arrangements.
Definition of terms under Jefferson's method. In Jefferson's method, there are 8 terminologies that are commonly used, and for the first one, we have apportionment. It is the process of distributing a fixed number of seats among several states, parties, or groups in proportion to their population. And for the second one, we have the house size. It is the total number of seats available to be divided among the groups, and this number is fixed in advance. For example, 10 seats, 435 seats, or 15 seats, or 20 seats, etc., as long as it is a fixed number. For the third one, we have the population. It is the number of people or weight or votes in each group. This actually determines how many seats a group should ideally receive. And for the fourth one, we have the standard divisor. It is the people per seat number found by dividing the total population by the total number of seats. We are down to the fifth one, which is the quota. This is the exact or possibly fractional number of seats a group should receive, found by dividing the group's population by that divisor. Now we have the lower quota. The lower quota obtained by rounding down the quota. Jefferson's method always uses the floor value, never rounds up, or never the upper quota. Now, for the seventh one, we have the modified divisor, a specially adjusted divisor used instead of the standard divisor. Since rounding down often leaves some seats undistributed, the divisor is reduced until the sum of all lower quotas matches exactly the house size. And now for our last one, we have the fair share. the proportional number of seats a group deserves under the perfect equality. This is essentially the same as the standard quota.
So these are the steps or procedures of the Jefferson method. First, determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This insert is called the standard divisor or divisor. Next step is divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Third step is cut off all the decimal parts of all the quotas, but don't forget what the decimals were. These are the lower quotas or initial apportionment, and add up these whole numbers. This answer will always be less than or equal to the total number of representatives. If it's not equal to the total number of the representatives, we should be done, or we would be done. But if it's not, then we go to step 4. If the total from step 3 was less than the total number of representatives, reduce the divisor and we calculate the quota and allocation. So if we have leftover total representatives, we actually modify the divisor rather than using the decimal parts of the quotas. And we actually change the divisor, and in Jefferson's method, we reduce the divisor. We continue doing this until the total from step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. So that's all for the steps and procedures of the Jefferson method.
Now that we know what Jefferson's method is all about, its description, its introduction, its steps and procedures, let us now move on to a sample problem for you to know how to apply the Jefferson's method. Now for our sample problem, it states here, or the given here is, Delaware has 3 counties: Kent, Newcastle, and Sussex. The Delaware State House of Representatives has 41 members. Now, use Jefferson's method to apportion 41 members among 3 counties. Now on your right, you can see a table that has a given data. Now for the county, again, we have Kent, Newcastle, and Sussex. Now, the populations are the given. For Kent, we have 162,310. For Newcastle, we have 538,479. Now for Sussex, we have 197,145. Now in total, for the whole population, we have 897,934.
Step 1. Find the standard divisor. The total population is 897,934 people. The total sets is 41. We calculate the standard divisor by dividing 897,934 divided by 41 equals 21,900.82. This means each set represents 21,900.82 people.
Step 2. Calculate the standard quota. Now, we divided each state population by the standard divisor, 21,900.82. So, Kent is 162,310 divided by 21,900.82 equals 7.411. Newcastle is 538,479
21,479 divided by 21,900.82 equals 24.587. Sussex is 197,145 divided by 21,900.82 equals 9.002. Step 3. Find the lower quota. We take the whole number part of each standard quota. Kent is 7.41127. Newcastle is 24.587 to 24. Sussex is 9.002 to 9. Now we add them up. 7 plus 24 plus 9 equals 40. We need 21 sets, so the total is too small. We need to lower the divisor. Step 4. Adjust the divisor. Lower the divisor until the sum of the lower quota equals 41. A suitable modified divisor is 21,538.83. Step 5. Recompute quotas using this modified divisor. Kent is 162,310 divided by 21,538.83 equals 7.535. The lower quota is 7. Newcastle is 538,479 divided by 21,538.83 equals 25.0. The lower quota is 25. Sussex is 197,145 divided by 21,538.83 equals 9.153. Now add them. 7 plus 25 plus 9 equals 41. Therefore, the final sets is Kent have 7 sets, Newcastle 25 sets, Sussex 9 sets.
So here it is, everyone, the final answer. Therefore, the final seats are 7 seats for the County Kent, 25 seats for the Newcastle, and 9 seats for Sussex.
Now, after all has been discussed, here's one of the conclusion about the Jefferson's method. Jefferson's method is a divisor-based apportionment algorithm that ensures a fixed total number of seats are distributed in approximate proportion to population. It works by choosing a modified divisor, derived by adjusting the standard divisor, dividing each stage or groups population by the divisor, rounding down to get each group seats, their lower quotas, adjusting the divisor via trial and error until the sum of seats equals to the total seats available. This method favors larger population over small ones because rounding down tends to under-allocate for smaller states more severely. It satisfies several desirable properties like house monotonicity, consistency, and lower quota, but may violate the upper quota requirement. Now, here's the generalization of the Jefferson's method. Jefferson's method generalizes to any situation when you have a total quantity to allocate, like seats and resources and etc., a set of weights or population for subunits. This is the desire that allocation be proportional to those weights. The requirements that the allocation must be an integer and sum exactly to the total. In general, divisor methods, of which Jefferson's is one, form a family. What distinguishes them is how you round down, up, nearest, and etc. Jefferson's is the version that always round down, adjusting the divisor until the total fits.
Okay, thank you so much everyone for your discussion on Jefferson's method. Now here in front of you, as you can see, are the references and sources that me and my members have used to make this video possible. This was format and made by our one and only Mr. Saguban. And I will be personally putting this in the description down below. So if you have time to copy and paste it, and if you want to see the facts for yourself on Jefferson's method, go ahead and copy and paste the links and references and see for yourself. Thank you so much for watching, everyone. Until next time.